Assalamu alaikum. Welcome to the 8th lecture of Software Quality Assurance. In the last lecture, we talked about requirements and the software requirements engineering process. We discussed different kinds of requirements, and we tried to associate different quality aspects to different aspects of software requirements. Today, we will continue our discussion on software requirements and software quality assurance. Today, we will talk about requirements problems and requirements defects, and also we will talk about how to write good requirements. That is, we'll discuss some guidelines on writing software requirements. These guidelines will enable us to develop high quality requirement set, which can then be translated into high quality software design. It is very important that we document the requirements accurately and with high quality, so that not only they meet the customer's real needs and requirements, but also they are internally consistent and unambiguous. So let's discuss some of the requirements problems that we face in this profession. One of the problems is that the requirements do not reflect the real needs of the customers for the system to be developed. And this is a problem, this is a very serious problem, because then it results in a development of a software system which is of no use to the customer. And why does this happen? It happens because the requirements engineers are not trained properly to gather requirements accurately. And also because many times customers are not sure of what they need. They express what they want. And remember, when we initiated discussion on requirements, we said that requirements include both the needs and the wants of the customer. And so it is the job of requirements engineers to find what the real needs are and develop a high quality requirement set that meets those needs. Sometimes we find that requirements are inconsistent and or incomplete. There are two things here. One is inconsistency and the other is incompleteness. For large complex systems, we must strive to have as complete a requirement set as possible. However, we must also realize that the requirements will change as the customers become fully aware of the potential of the new software system. And some of the changes will be recommended by the development team. And so to get an absolute set of accurate and absolute set of complete requirements for large complex systems is not possible. But we must strive for internal consistency. And if there are inconsistent requirements within the documented set of requirements, then that software system is bound to create problems for the customers at the end of the development cycle. Because then you would have conflicting requirements that will be in the product. However, we do have a validation phase as or validation activity as we discussed in the last lecture. But we should understand that we should perform validation specifically very carefully with respect to checking for inconsistencies. And why would we want to do that is because making changes to requirements after they have been agreed upon is very expensive. And if we make changes to the requirements during the requirements engineering process, it is relatively cheaper to make those changes. There are misunderstandings between customers, those developing the system, that is the development team, and the software engineers who are maintaining the system. And these misunderstandings are because the requirements have been misinterpreted. So another problem with requirements is that the requirement set can be misinterpreted if there is ambiguity in them. Usually the requirements are written as complex conditional statements. For example, it would say if A, then B, else C, or else something else. And this sort of documentation is confusing. The requirements should be stated as simply as possible without having to do with too much complexity, without having to contain a lot of conjunction. And we will see the guidelines, we'll discuss the guidelines for writing requirements later in the lecture today. Sometimes the terminology used is sloppy and inconsistent way. Somewhere the requirement writer or the customer will use one term to mean one thing, and at another part of the document or in another setting, the customer would use the same term to mean something else. And this can obviously, understandably, cause a lot of confusion for requirements engineers and for designers. This is a serious problem, and we as requirements engineers need to clearly document the way terminology is used and be consistent in the use of the terminology. Similarly, the requirements writers assume that the readers have specific knowledge of the domain or the system, and they know the essential information about that application domain as well as that application software. Now, that is not the case in many situations, because the requirements document is usually written once. What I mean by that is the requirements document is written once in large part, and then amendments can be made to it. However, that same requirements document is read over and over again by designers, by developers, by people who are planning and writing tests, and a lot of managers and customers. And so it has to be written in such a way that it is understandable by all of them, and it should avoid complex domain-specific terminology. Whenever a terminology is used, whenever domain-specific acronyms are used in the requirements document, they should be explained elsewhere within that requirement document. So this is another problem that we face in documented requirements. It is difficult to check for requirements errors and omissions, and so we cannot directly test requirements. The requirements are not executable statements. So what happens is if there are errors in the or problems in the requirements document, it becomes difficult for us to test them and to check them. And if the requirements are misinterpreted, then it may lead to contractual disagreements between customer and the system developer. And we remember discussing the probability of litigation in case of contractual disagreements and the cost involved with that. It is the loss of work that is probably the most important, but still in situations like that, these cases can end up in courts of law. Another problem is that when requirements are late, and now we are discussing the impact of wrong requirements. When requirements are wrong, systems are late, they are unreliable, and they don't meet the needs of the customers, which results in enormous loss of time, loss of revenue, loss of market share, and most important is the trust of the customers. If customers lose trust in one vendor, one software developer, probability is that they will not use that vendor's products, other products also, even though other products may be of high quality. One of the things that we talked about was that if the requirement set is not accurate, it's not of high quality, that is, it does not meet the real needs of the customer, then conformance to such requirements is going to result in a wrong system. And if you develop a wrong system, that is again an enormous loss of time, loss of revenue, loss of trust for that customer. So there are serious problems that we have to address and take them with seriousness, that we need to address them and rectify the problems that occur in the requirements engineering processes. All of these things have direct relationship with software quality and software quality assurance, because if the quality of requirement set is not high, if the requirement set does not meet the real needs of the customers, then what's the point of developing the software requirements? Why spend so much money and why spend so much effort in going through the software requirements engineering processes if at the end we are going to get a wrong set of requirements? And so each step from elicitation to analysis and negotiation, from requirement to requirement specification, requirements validation, requirements management, everything has to be done with high quality perspective. It has to be done in such a way that it meets the highest possible quality standard set for that particular project. And with that continuous effort, we can be sure that the agreed upon set of requirements is of high quality and it meets the quality criteria, quality attributes for software requirements engineering. We will talk about these different quality attributes in the next lecture. Now let's talk about requirements defects. We have said before that requirements is a source of many defects. If we analyze requirements, we find that all four kinds of software defects are found in requirements. These 4 kinds are errors of commission, errors of omission, errors of clarity and ambiguity, and errors of speed and capacity. If not prevented or removed, requirements defects usually flow downstream into design, code, and ultimately into user manuals. And added defects also get from design and code, and so this is like a cumulative effect or a snowball effect where defects are attracting more defects, which are attracting more defects, and as a result, at the end of the life cycle, we have a large number of defects which will then be discovered by the customer. And defect discovery by customer is quite embarrassing, and fixing those is quite expensive. Historically, requirements defects are most expensive and troublesome to eliminate. Therefore, every effort should be made to eliminate requirements defects during the requirements engineering process. Now, as I said, that if we don't do that, these are going to have a snowball type effect, and these requirements defects are going to add or going to create design defects. This is one thing, and then there will be some original design defects, and then all of the defects will go into the coding activity, and requirements defects plus design defects will create coding defects, and design defects will create coding defects, and then there will be additional coding defects. So you can see the cumulative effect of not paying enough attention to eliminate requirements defects. So it pays us to, in the long run and even in the short run, to spend time and resources in elimination of requirements defects. For requirements errors, prevention is usually better than removal. So because most of the requirements errors are due to non-understanding of domain, or not understanding or not uncovering the real requirements of the real needs of the user. So therefore, if we invest in prevention techniques, then the results can be much better, because removal is not as effective as prevention for requirements defects. Now let's talk about different kinds of different categories of errors in requirements. Errors of omission are most common in requirements. These are errors which mean that something has been missed out of the requirements, and again it points out to the fact that many requirements engineers are not fully trained or fully educated about the application domain, and as a result they miss out on sometimes fundamental things in the application domain. It is not the fault of requirements engineers entirely. Sometimes customers also find it obvious and that a requirements engineer would know the fundamentals of the application domain, and they do not convey these fundamental things to the requirements engineers properly. But as professionals, it is then the responsibility of requirements engineers to understand the application domain so that they can ask relevant questions, they can read necessary documents, and they can gather requirements from other sources so that a knowledge base of the application domain is developed for them to carry out their assignments. It is very important for application domain to be fully understood, or at least understood to a level where the requirements engineers are comfortable with the basic terminology and the fundamental working of that application domain. There is not much emphasis that can be made on the importance of knowing about application domain. This is the only way that we can prevent errors of omission and finding their way to our requirements documents. Second most commonly occurring requirements errors are that of clarity and ambiguity. And this is also very intuitive. It's very easy to understand why this happens, primarily because natural languages like English or Japanese or French or other spoken languages are used to state requirements. On the other hand, these languages are themselves ambiguous. Most of the spoken languages are context dependent. So a phrase or a word would mean different things in different contexts, and as a result the meaning of the words will change, and if that is the case, then requirements will always be somewhat ambiguous if they are stated in natural languages. So what do we do with them? We have to use some structured languages, or we have to use mathematical languages to explain the natural language statements. And this has been done in computer science for the last 40 or so years, and there have been a number of modeling languages developed, and UML is one of them, which helps the requirements, which helps in the clarification of requirements stated in natural languages. Errors of commission can also find their way into the requirements document. This would be a result of a conflicting requirements coming from more than one stakeholders, and the requirements engineer making the wrong choice and putting them in the requirement set. Similarly, performance errors can also be found in the requirements document. This again would be the case of where stakeholders provide different information, and as a result the requirements engineer not having the relevant domain information and selecting those candidates which are not accurate. Now, as I said, that prevention works better for requirements error than removal. There are a number of techniques that can be used in preventing software requirements errors. The first one, which is really not a technique but an advice, and that is a common sense advice, and that is the acquisition of domain knowledge. Learning about domain is of paramount importance. One cannot emphasize it more. But there are other techniques also. For example, joint application development, JAD, quality function deployment or QFD, and prototyping are more effective in defect prevention. Requirements inspections and prototyping also play an important role in defect removal. But the key, again, I have to emphasize this point again, over and over again, and that is that as requirements engineers, if you are interested in developing a high quality set of requirements, study the domain, find out what the application, what are the constraints, what are the problems in that application domain, what are the factors which influence that application, and if you don't fully understand, keep trying, consult the domain experts, try to read about the domain from different sources. There is plenty of material available about almost every domain in the world on the internet. So internet is a great source. There are sites like Wiki, which can summarize all the information, and that can be a wonderful starting point to get knowledge about any application domain. And then continue to build on top of it, and then ask relevant and good questions from the domain experts. And once you have built a basic knowledge base, then you can have good discussions with the domain experts. Another problem with the requirements is that they keep changing, or they are also known as changing or creeping requirements. As I said before, that completeness, although a very important goal, but for complex and large systems, it is almost unachievable, because the requirements continue to change as the understanding of the customer as well as of the development team improves about the project. And also during the application development, sometimes the priorities of the customers change, and sometimes the business areas change. So requirements will change no matter what. We have to be comfortable with that. We have to accept that. A major issue, however, in requirements engineering is the rate at which they change once the requirement phase has actually ended. And so we know that we cannot eliminate, or we cannot stop requirements from changing. What we do have to do is to manage this change. During the execution of the requirements engineering activity, the rate of change will be high, but once that activity officially ends, that rate should come down to something like 3% per month in the subsequent design phase, and in the coding and testing phase, this should be even lower. So during coding it should be 1%, and during testing it should be 0. And that is for one iteration, because most of the software development now is done in using iterative software engineering process models. So requirements will change. We have to learn to live with it. We have to learn to manage it. But there's also another side to it, and that is that studies have shown that very significant percentage of defects delivered can be tracked back to the creeping requirements. And so you have to realize that the requirements, when they are changing, are introducing defects. Let's say requirements are changing at the when the code is being written. You have to redo some of the design, you have to redo some of the coding. And so this process is naturally going to add some defects into it. So whenever there is a change in requirement, when the requirements have been officially and when the requirements engineering process has officially ended for that iteration, the level of care and level of cautiousness has to go up substantially, because the impact of these change in requirements can be devastating in many cases. This realization, that is the delivery of defects related to creeping requirements, can only be achieved if defect tracking, requirements traceability, defect removal efficiency, and defect rates are all monitored for software projects. So these are the things that are directly related to quality assurance, as we have discussed them in the first phase of this course. In the first phase, we talked about the need for defect tracking, we talked about defect removal efficiency and defect rates, repair rates, and we talked about requirements traceability in the last lecture. And so all of these concepts are now coming together, sort of the SQA concepts and the requirements concepts, and together they result in high quality software requirement set. Now what happens, what can we do to control the damage done by creeping requirements? We can use a number of quality assurance mechanisms to limit the damage done by these changing or creeping requirements. First of all is to have a formal change management procedure in place. To support that, we must have state-of-the-art configuration control tools. The first two are related. First is the procedure and policy. Second is the state-of-the-art tools supporting that or implementing that policy and procedures. And third is the formal design and code inspections. We have had a little bit of introduction on what inspections are, and we will have specific lectures set aside on software inspections. So we'll talk about what software inspections are at that time. Since the languages that are used for recording requirements are mostly spoken languages, also known as natural languages. So let's look at some of the problems that we face in natural languages. Number one, there's lack of clarity. And then there is requirements confusion. It's not clear what the requirement means. And then third, we have requirements amalgamation, meaning that a number of requirements have been written together. It's the way they have been written that it appears that it's only one requirement, but in fact there are lots of them in one requirement. Natural language understanding relies on the specification readers and writers using the same words for same concept. What this means is that since the requirements are written by requirements writers or requirement writer, he or she uses a particular terminology and assume that readers would use the same concept or would mean the same thing when they read this terminology. And so there is a possibility, here is a possibility of misinterpretation. A natural language requirement specification is over flexible. You can say the same thing in completely different ways. And whenever you have that opportunity and you apply this, you say one thing in one way in one place, and you say the same thing in another way in a different part of the same document, then that can be a problem. Although this would be a great feature to use in as a feature of the language. However, we in requirements engineering and quality assurance would not appreciate that very much. It is not possible to modularize natural language requirements. It may be difficult to find all related requirements. For example, there is no compulsion to record all the requirements related to one particular thing at the same time, at the same place. And so to discover the impact of change, every requirement has to be examined. And that is a problem for very large set of requirements. If you have 1,000 to 10,000 sets of requirements in the requirements document, and then you have to read through to find out, or at least search those requirements, is a time-consuming factor. Let's now look at the guidelines for writing requirements and discuss these guidelines so that we can write our requirements which are which contain or which are consist of high quality attributes. Requirement specification should establish an understanding between customers and suppliers, that is software development team, about what a system is supposed to do, and provide a basis for validation and verification. And so this is that goal, that the requirements should be a mechanism of communicating in technical terms what the customer will get as a result of the effort done by the supplier. Typically, requirements documents are written in natural languages, as we have discussed, and these are ambiguous themselves. So what we do is we take the help of structured languages, and these structured languages consist of unambiguous notation, and they also contain graphical notations, which would mean that a certain diagram cannot be misinterpreted. And so we use these graphical notation or structured languages to help remove ambiguity or to add clarity to the requirements statements which are documented in the natural languages. There are a couple of problems with these structured languages also. Number one, these languages cannot be used to completely define requirements, and number two, they are not understandable by all the stakeholders, while the natural languages are understandable by all stakeholders. Let's develop a foundation for writing requirements. So we'll discuss what are the essential things for writing requirements. Requirements are read more often than they are written. So investing in writing requirements which are easy to read and understand is almost always cost effective. So as a quality assurance mechanism, the requirements writers should be provided training on how to write good requirements, how to write high quality requirements. Readers, on the other hand, come from diverse backgrounds. Requirements writers should not assume that all readers have the same background and knowledge as the requirements writers. Requirements writers usually have much more knowledge about what they are writing as compared to those people who are reading. Not always true, but usually. Writing clearly and concisely is not easy. If you don't allow sufficient time for requirements descriptions to be drafted, reviewed and improved, you will inevitably end up with poorly written requirements. So there is a time factor involved in the process of documentation of requirements and the a review of those requirements, and with the review comes an improvement which is natural. Different organizations write requirements at different levels of abstraction, from deliberately vague product specifications to detailed and precise descriptions of all aspects of system. Not only this varies from organization to organization, but it also varies from domain to domain. We have discussed the level of abstraction and level of detail of requirements in the last lecture. And so these are like the ground realities of what happens in the requirements world. Level of detail that is needed is dependent on few things. For example, type of the requirements, stakeholder or process requirements. Customers' expectations is also an important factor in determining the level of detail at which you would want to document the requirements. There are organizational procedures, both for the development team as well as the customer side. Their processes have to be taken care of, have to be understood, and they play a factor in selecting to the level of detail for documenting requirements. And there are external standards or regulations which require that requirements be stated in such level of detail. And so we know by now that writing requirements is a tough job, and writing good requirements needs or requires analytic thought, and providing good education and training to requirements writers would enable them to have that kind of thought process. Another way to convey that analytic thought to the rest of the readers of the document is to record rationale for that requirement. Why was this requirement selected? And it also helps a lot in traceability, although I'm not going to discuss that aspect now, but that still is a quality assurance phenomena that has to be taken care of for requirements. But so in order for us to convey why a particular requirement was selected, is that we convey its rationale also. And with that, we conclude the discussion on essentials for writing requirements. Now let's see what are the guidelines for writing good requirements. As you can see, there are 3 criteria. These are the first 3 criteria or guidelines for writing requirements. Number 1, define standard templates for describing requirements. Number 2, use language simply, consistently, and concisely. Number 3, use diagrams appropriately. Let's discuss each one of them now. The first one was use of standard templates, or the first one relates to the use of standard templates. Here you have to define a set of standard format for different types of requirements and ensure that all the requirements definitions adhere to that format. This is a procedural matter, but very important. Standardization means that omissions are less likely and makes requirements easier to read and check. And so if we just use standards, we have inculcated a process which is going to reduce things that can be missed or omissions, which makes easy for us to read the requirements and analyze them and check them while writing those requirements. The second point that we discussed was about the use of language so that it is simple and consistent. We have discussed this before, that languages can be used in a variety of ways. But for requirements, we suggest that you use them consistently. In particular, we have to distinguish between what is mandatory and what is desirable. That is, mandatory requirements or desirable requirements. It is a usual practice to define mandatory requirements using the shall statement, and the desirable requirements with should statement, and will is used to state facts or declare purpose. So if I use shall as a mandatory requirement, then any reader will have no confusion between the word shall and the word will. Shall will always mean mandatory requirements. Continuing on with the concept of using simple language, we suggest that to use short sentences and paragraphs, using lists and tables, using text highlighting to pick out key parts of the requirements. And so these are again things which help the reader. So things that you pay attention to in writing are going to help the readers. Use of diagrams to present broad overviews, show relationships between entities is a good thing. But on the other hand, you should avoid using complex diagrams. Complex diagrams with very small font writings can add more confusion and are of not that of that use. Here you see two more guidelines for writing requirements. The first is supplement natural language with other descriptions of requirement, and second is specify requirements quantitatively. Now, if the readers of the requirements document are comfortable with other descriptions like equations, especially for scientific and engineering and medical domains, use of domain-specific terminology and equation is going to simplify and elaborate those requirements for domain users, and it is going to, for the designers, it is going to give them a proper guidance as to what is meant by this requirement. So we don't suggest that you write everything in the natural language. You can use equations, and domain-specific terminologies can also help. The second point that you just saw was the specification of requirements in a quantitative way. Wherever possible, quantify the requirements. For example, if you're talking about reliability or performance or other quality attributes, use quantification because it is applicable to the properties of the system. And we discussed these things when we talked about non-functional requirements in the last lecture. There are a couple of, there are few more guidelines which are corollaries to these discussions that we have had on guidelines for writing requirements. The first one is that state only one requirement per requirement statement. That is, don't amalgamate too many requirements together. Try to write requirements as active sentences. always use noun or a definite pronoun when referring to a thing. Do not use more than one conjunction when writing requirements statements, because they add confusion and are open to misinterpretations. Avoid using weak words and phrases. Such words and phrases are generally imprecise and allow the expansion or contraction of requirement beyond their intent, and that is again related to the misinterpretation aspect of the requirement. These words include, for example, about, adequate, and or, appropriate, as applicable, as appropriate, if practical, suitable, timely, typical, when necessary. So these words are always open to interpretation and are ambiguous. Try to write requirements without telling them how they will be implemented. Try to write complete statements. Write statements that clearly convey the intent, so the ambiguity should be removed from these requirements. And so today we had a good discussion on writing requirements. We discussed different guidelines, different important aspects for writing high quality requirements. But before that, we talked about what are the problems that we face in requirements, the kinds of defects that are prevalent in requirements documents, and hopefully when we follow these guidelines for writing high quality requirements, we will be able to eliminate many of the requirements defects. And in the next lecture, we will talk about quality attributes of software requirements documents. Allah Hafiz.